Welcome students, welcome to the video class. Today we will discuss some numericals based on magnetic field due to a bar magnet at any axial point or equatorial point. ठीक है? And next we will do some okay. Next we will discuss torque on a magnetic dipole placed in a uniform magnetic field. ठीक है? Okay. Okay, ଆମେ last data video रे we have discussed the two long question, that is magnetic field due to a bar magnet at any axial point and equatorial point, and ଟିକେ ଏଟାକୁ revise କରିବା, then we will move to do some numerical based on this. ठीक ଅଛି? Okay, first we have discussed was magnetic field due to a bar magnet at any axial point. So we have taken a bar magnet and from r distance from the center of the bar magnet we have taken a point on the axial line. ठीक है? So at point B the magnitude of magnetic field due to the bar magnet was B net is equal to mu naught 4 pi 2 mr divided by r square minus l square of whole square, and the direction was from P to B, or I mean best कही पर it is south to north. ठीक है? And if it is an ideal dipole, so in that case B net is mu naught 4 pi 2 m by r cube. काहेकि for an ideal dipole length is very small, यदि L टा छोटो थियो L स्क्वायर टा आहुरी छोटो थियो, तो सेत पे L स्क्वायर टर्म टा हम नेग्लेक्ट कर देले, तो हमर आसला P net is equal to mu naught 4 pi 2 m by r cube, and the direction is from south to north. Remember that this amro magnetic dipole moment रे मध्य हमें बाहर करथिले, its direction is also from south to north. तो magnetic dipole moment रो direction जोटा magnetic field, net magnetic field due to bar magnet at any axial point or direction was the same, that is from south to north. ठीक है? Next is हम second long question derive करथिले कि magnetic field due to bar magnet at any equatorial point. We have taken a bar magnet and this was the equatorial line and P is the equatorial point, so which is r distance from the center of the bar magnet. So in that case the net magnetic we found was B net is equal to mu naught 4 pi mr divided by r square plus l square to the power 3 by 2, and the direction was from px, or it best coherent is from north to south because px direction जो north to south direction was the same. And if it is a ideal dipole, if the bar magnet is an ideal dipole, length is very small, so L square is very small, so B net कहता है mu naught 4 pi m by r cube. ठीक है? अब उड़े को शॉर्ट क्वेश्चन हमारा से, what is the ratio of net magnetic field due to bar magnet at any axial point to the equatorial point? ठीक है? तो बाहर करिए, तो हमारा B net axial point रो axial point का था, that is mu naught 4 pi 2 m by r cube. B net equatorial point का था वो mu naught 4 pi m by r cube. ठीक है? यदि दीटा को डिवाइड करिबा तो mu naught 4 pi mu naught कटि जो 2m को m जे डिवाइड करिया mm कटि जो रहइबो 2 and r cube कटि जो. ठीक है? तो आंसर केते आसो, that is this is 2 eta 1. So the ratio is 2:1. So we can say the ratio of net magnetic field due to bar magnet at any axial point to the equatorial point is 2:1. Short question में होता है. ठीक है? Okay. Next we will do some numerical based on these formulas. The first question is, what is the magnitude of the equatorial and axial fields due to a bar magnet of length 5 cm at a distance of 50 cm from the midpoint? the magnetic moment of the bar magnet is 0.4 ampere square. ठीक है, चलिए 0.4 ampere meter square. Okay, before starting or before doing any question related to this magnetic field due to a bar magnet at any axial or equatorial point, first कौन करियो, check करियो the length and the distance of the point where its effect could be felt, or distance of the point where the magnetic field is to be found. So if suppose, let us in this case, here the length is 5 cm and this r is 50 cm. Remember, if L is nearly equal to R or slightly छोटो छोटी के, तो in that case use this formula. ठीक है, if second case, if L is less than R, तो if L is less than R, in that case it is an ideal dipole, तो use this formula. तो यदि हमें a question देखिबा, in this question this L is 5 cm, R is 50 cm, तो R is 10 times that of L. तो say case रे we will use this formula, because the distance where the effect could be felt, that is the distance where the net magnetic field is to be found, that is R, is greater than this L. So in that case it is an ideal dipole. We will use the formula of ideal dipole of axial as well as equatorial. ठीक है, okay, तो हमें यूज करिबा ideal dipole formula in this case. ठीक है, okay, given लिखि दबा, that is given is L is equal to 5 cm, or that is 5 into 10 to the power minus 2, or that is 0.05, and R is 50 cm, or that is 0.5 meter. ठीक है, and third is magnetic moment दीजिए, that is 0.4, that is M is equal to 0.4 ampere meter square. Again author for the, what is the magnitude of equatorial and axial field due to a bar magnet of length 5 cm at a distance 50 cm from the midpoint. 50 cm from the midpoint means R, and the magnetic moment of the bar magnet is 0.4. ठीक, तो axial formula कौन होगा, or that is B net due to axial, that is mu naught by 4 pi, that is 2m by r cube. Ideal में पकड़े, that is mu naught 4 pi के था 10 to the power minus 7, this into 2, m is how much, तो m is 0.4. ठीक है, and this is r is how much, 0.5 whole cube. So this is तो वैल्यू कहता है, so that is this is 4 to the 0.8 divided by 0.25, sorry 0.5 whole cube, that is 0.125. तो यदि डिवाइड करें तो आंसर आएगा 6.4 into 10 to the power minus 7 टेस्ला. ठीक है, सेकंड इज B net equatorial, that is mu naught by 4 pi, that is m by r cube. तो एटा जहाँ आसिला, तो एटा कौन तार अधा, ये 2m by r cube, this is m by r cube. Put the value, तो आंसर टा कौन लिखो, दैट इज हाफ. दिस इज 3.2 into 10 to the power minus 7 Tesla. ठीक है. Okay. Next we'll move to the next question. Next question is, a bar magnet of 10 cm has a pole strength of 10 ampere meter. Calculate the magnetic field at a distance of 0.2 meter from the center at a point on its axial and equatorial line. ठीक है. So again, this a bar magnet of length 10 cm. So L is equal to 10 cm. Length of the bar magnet, that is 2L, is equal to 10 cm. And pole strength of the bar magnet is 10 ampere meter. ठीक है. Calculate the magnetic field at a distance of 0.2 meter. So R is 0.2 meter, or that is 20 cm. तो ये L कहते हैं, that is 5 cm. When you consider 5 cm and this is 20 cm, तो it's not so less. This is बहुत छोटा नो. If you compare L with R, L is not so small. बहुत छोटा नो है. तो हमें आइडियल डाइपोल रो फॉर्मूला यूज करबा नहीं. We will not use the formula of ideal dipole. ठीक है. तो what is the formula? The formula of that is, so B net is equal to, that is mu naught by 4 pi, that is 2m r divided by r square minus l square whole square. ठीक है. And for that हमको दरकार, that is dipole moment. Dipole moment बाहर करे प्रथम रे, magnetic dipole moment is equal to m into, that is 2l, that is m कहते हैं 10, 2l कहते हैं 10 cm. 10 cm means 0.1, 0.1 meter, that is equal to, that is 1 this ampere meter square. ठीक है. Okay, ये फॉर्मूला यूज करें, that is magnetic field at any axial point. So this is लिखी दबा equatorial रो मध्य फॉर्मूला टा, that is mu naught by 4 pi, that is mr divided by r square plus l square to the power 3 by 2. ठीक है. authority question पढ़िबा. A bar magnet of 10 cm has a pole strength is this. Calculate the magnetic field at a distance of 0.2 meter from the center. So r is 0.2. You have to find the magnetic field at any axial and equatorial point. तो formula पकेगा, this is mu naught 4 by 10 to the power minus 7. ठीक है. This is 2. m कहते हैं सिला, that is 1. r कहते हैं, that is 0.2 divided by, that is point r is how much? R is, this is 0.2 रो whole square. L is how much? That is point. ठीक है. So this is equal to, this is 10 to the power minus 7 into, this is 0.4 divided by, this is 0.04 minus 0.0025, that is equal to, that is 0.03375. ठीक है. तो होल स्क्वायर, एटी गोटे होल स्क्वायर छाड़ी, तो ये होल स्क्वायर. तो वैल्यू आसो, that is 2.84 into 10 to the power minus 5. टेस्ला। ठीक है, तो net magnetic field on the axial point is given, answer is 2.84 into 10 to the power minus 5 Tesla. Equatorial point form पकेगा, this is 10 to the power minus 7, that is m is how much, m is 1 into r is how much, 0.2 divided by r square, that is 0.2 the whole square plus l square, l is how much, 0.05 the whole square to the power 3 by 2. ठीक है, तो आंसर इज 1.14 into 10 to the power minus 5 Tesla. ठीक है, तो the value of magnetic field at axial point is 2.84 10 to the power minus 5 Tesla, and equatorial point is 1.14 into 10 to the power minus 5 Tesla. ठीक है, next is torque on a magnetic dipole in a magnetic field. Again, this torque on a magnetic dipole in a magnetic field. Okay, before moving to this, did the छोटे point discuss करना that will be used in this section. ठीक है, first is हमें जानी चाहिए कि यदि गोटे magnetic field रे जदि गोटे आइसोलेटेड पोल गोटे रखिबा तो तापर गोटे फोर्स पड़िबो, दिस फोर्स इज इक्वल टू पोल स्ट्रेंथ इनटू मैग्नेटिक फील्ड. ठीक है, इफ इट इज ए नॉर्थ पोल तो जो मैग्नेटिक फील्ड एक्सटर्नल मैग्नेटिक फील्ड अछि, we know that magnetic field lines always starts from the north pole ends in the south pole. तो ये जो एक्सटर्नल मैग्नेटिक फील्ड रो इटा नॉर्थ थिबो इटा साउथ थिबो, तो this isolated north pole will be attracted towards the south. That's why force through direction of along the direction of magnetic field, external magnetic field. ठीक है, जदि एटा साउथ पोल था, if it is a south pole, then south pole will be attracted towards the north. तो force or direction कौन था, like this. ठीक है, magnitude both the case is same but direction is different. North pole थे along the direction of external magnetic field, south pole थे opposite to the direction of external magnetic field. ठीक है, next is आउ गोटे जिनस वाला couple. couple. तो what is a couple? First year में पढ़ी two equal and opposite force. Two equal and opposite force separated by a distance. Separated by a distance is called a couple. Is called a couple. Two equal and opposite force separated by a distance is called a couple. This couple produces a turning effect. Example, so let us say this cape of this pen. ठीक है, जदि एटा को मु एमती करूची, it is rotating. That means जतबे मु एमती करूची दीटा फोर्स पकोची, एपटे फर्स्ट फिंगर रे गोटे फोर्स पकोची एंड सेकंड फिंगर रे आ गोटे, एटा जदि एमती हबो एटा उल्टा डायरेक्शन. लेट अस से दिस इज पुशिंग दिस, तो आरटा कोन होची उल्टा डायरेक्शन में करूची, लाइक दिस. दैट मींस मु दीटा फिंगर रे इक्वल एंड ऑपोजिट फोर्स पकोची ऑन दिस कैप. दैट्स व्हाई इट इज रोटेटिंग. ठीक है, so that means we can say couple produces a rotating effect. Couple produces a rotating effect. ठीक है, consider a bar magnet. Consider a bar magnet AB. having pole strength m, and the magnetic length is 12, placed in an uniform magnetic field B, placed in a uniform magnetic field of strength B. ठीक है, and this bar magnet is making an angle, this is theta, with the magnetic field. ठीक है, again I am saying, consider a bar magnet AB having pole strength m and magnetic length 12. Let the bar magnet is placed in a uniform magnetic field of strength B such that it is making an angle theta with the magnetic field. ठीक है, तो आमे जानिचे जदि गोटे pole is placed in a magnetic field, it will experience a force. North pole will experience a force along the direction of magnetic field, and south pole will experience a force opposite to the direction of magnetic field. So this is the north pole, so it will experience a force in this direction. ठीक है, and the magnitude कौन होगा, that is pole strength of the north pole into magnetic field. Similarly, so since it is the south pole, it will experience a force opposite to the direction of magnetic field. So direction कौन होगा, like this. Okay, so force और magnitude कौन होगा, same. So that means we have two equal and opposite force acting on the bar magnet. ठीक है, due to this a couple will act on it. Due to this a couple will act on this bar magnet. Okay, the torque due to this couple is given by torque tau due to this couple is given by, this is force into perpendicular distance. ठीक है, this is the force because torque is equal to force into perpendicular distance. ठीक है, तो force in this case is m into b, perpendicular distance बाहर करियो. Okay, so let us drop a perpendicular like this and join this. So let us say this is O. ठीक है, तो in triangle this is AOB. So this is the hypotenuse, that is 2L, and this is the theta. Theta is the angle between magnetic length and this is AO. So this is the, if this is the force, this will be the perpendicular distance. इटा बाहर कर, let us say this is x. ठीक है, तो in triangle AOB, that is sin theta is equal to height by hypotenuse. Height is x, hypotenuse is 2L. So x is equal to 2L sin theta. So x is the perpendicular distance, that is equal to 2L sin theta. Put करिए, तो force is how much, m into b, and perpendicular distance is x, that is mb into, that is 2L sin theta. ठीक है, so this is b into, or this is m into, this is 2L experiment into b sin theta. M into 2L is magnetic moment, magnetic dipole moment. So M is equal, that is M into 2L. Magnetic dipole moment is equal to pole strength into magnetic length. So it is, that is M B sin theta. ठीक है, तो that is, the torque acting on this bar magnet is tau is equal to mb sin theta. ठीक है, and we know that this is a cross b is ab sin theta. A cross b is ab sin theta. तो एठी हम mb sin theta अछि, तो we can write this torque in vector form. Torque is equal to, that is m cross b. Torque is equal to m cross b. So this is the vector form of torque acting on a magnetic dipole in a magnetic field. ठीक है, okay. So what is the direction of this torque? Magnitude बाहर करो. This torque tau is equal to m cross b. Their magnitude is mb sin theta. So whatever the direction. So आमे जानिछे magnetic movement, magnetic dipole movement, the direction is from south to north. And this is, तो एठी हमर अछि, if you see this is the force and this is the magnetic field. The direction this, so b ro direction eta, and that is dipole movement ro direction abo from south to north, like this direction. So this is magnetic dipole moment ro direction. So angle kete hochi, that is dipole moment and magnetic field. This is the direction of magnetic field and this is the direction of dipole moment. So direction is theta. तो आमे जानिछे a cross b जदि थिबो in vectors, if a cross b is there, you have to rotate from a to b. A to b, the direction of thumb gives the direction of magnetic field. आमे कोन करथिले, if say this is if this is a and this is b and this is the theta, आमे rotate करूथिले from a to b, the thumb gives the direction. ठीक है, तो एठी आमे रोटेट करिया from m to b, तो डायरेक्शन कोन होबो, इनवर्ड. That means in this case the direction of torque is inward. ठीक है, आमे एमती लिख पारे, that is ठीक है. So the magnitude of torque acting on a bar magnet placed in a magnetic field is mb sin theta. In vector form it is m cross b. ठीक, and in this case it is, the direction is inward as per vector, as per this cross product of vectors. ठीक है, okay. Next we will find the maximum and minimum value of torque acting on this magnetic dipole. Torque tau is equal to m cross b, or that is mb sin theta. ठीक है, okay. If theta is 0, sin 0 is 0, so we can say that is torque tau is equal to mb sin 0, or that is 0. So we can say when theta is 0, the torque acting on the bar magnet or magnetic dipole is 0. So 80, theta is the angle between the magnetic field and the bar magnet. So theta is 0 को कैसे रहो, एमती. So that means in this case the torque acting on the bar magnet is 0. ठीक है, तो ए केस रे, तो ए जो एक्सटर्नल मैग्नेटिक फील्ड अछि, this is the north pole and this is the south pole. Magnetic field starts from the north pole, ends in the south pole. तो ए जो बार मैग्नेट अछि, this is the north, this is the south. तो फोर्स को डायरेक्शन पड़ो this, and south pole by force a direction, because north will be attracted towards the south and the south will be attracted towards the north. So this is the stable position for the bar magnet. ठीक है, if theta is 0, if theta is 90, sin 90 is 1. So then torque tau is equal to mb sin 90, or sin 90 is 1, so tau is equal to mb. So we can say torque is maximum when theta is equal to 90 degree. ठीक है. So this is my bar magnet, angle is this, theta 90 को किमती होगा like this. So in this position the torque acting on the bar magnet is maximum. ठीक है. Again this torque which is acting on the bar magnet, it tries to rotate the bar magnet co direction. तो एपटे गोटे फोर्स पड़ुछि, एपटे गोटे फोर्स पड़ुछि, तो दैट मीन्स इट ट्राई टू रोटेट द bar magnet in this direction to bring the bar magnet to this position, because this is a stable position, this is a stable position. और एमती भी कहि परियो. तो हमें जस्ट कहले two equal and opposite force separated at small distance is a couple. The couple will try to rotate the object. तो एठी मध्य two equal and opposite force पडुची, and this is the distance. Two equal and opposite force separated by a distance, that is x, and due to this the bar magnet will rotate. The bar magnet will rotate. ठीक है. And the bar magnet try to rotate to bring the dipole or this bar magnet to this position, because this is the stable position for a magnetic dipole. Next we will do a question based on this torque. Okay, the question is, a magnetic needle of magnetic moment 4.8 into 10 to the power minus 2 joule per Tesla is placed 30 degree with the direction of magnetic field of magnitude 3 into 10 to the power minus 2 Tesla. What is the torque acting on the dipole? Again, a magnetic needle of magnetic moment 4.8 into 10 to the power minus 2. So magnetic dipole moment is 4.8 into 10 to the power minus 2. Is placed 30 degree with the direction of uniform magnetic field. So angle is 30 degree. Magnetic field of magnitude this. So magnitude of magnetic field is, that is 3 into 10 to the power minus 2 Tesla. What is the torque acting on the dipole? So torque tau is equal to, that is m cross b, or that is mb sin theta. So m is how much? That is 4.8 into 10 to the power minus 2, and this is b is 3 into 10 to the power minus 2, and this is sin 30. So this is 4.8 into 3 into 10 to the power minus 4. Sin 30 is how much? Half. This is 2.4. So this is 7.2. 2.4 into 3 into 10 to the power minus 4. Okay, the torque is equal to, that is 7.2 into 10 to the power minus 4 joule. ठीक है.